my YouTube viewers. In this video, what we're going to be talking about is ARIMA. And ARIMA combines auto-regression, AR, and differencing, I, and moving average components to model and forecast time series data. And so what we're going to do is we're going to perform ARIMA on some synthetic sales data that we have created, and it's going to be monthly sales for 36 months. And basically, we're going to write a program in Python to do this, but in order to write the program in Python, we need to import some libraries. So we're going to import math, which is an inbuilt library in Python. We're going to import NumPy as NP, which is a numeric library. We're going to import pandas as PD, which is a data processing library and also creates data frames. We're going to import matplotlog.pyplot as PLT, which is a visualization library. And from statsmodels.gsa.arima.model, we're going to import ARIMA. And basically, statsmodels is Python's statistical library, and TSA is a module within statsmodels for time series analysis. ARIMA model is a module within TSA just dealing with just the ARIMA, and ARIMA is your auto-regression, differencing, moving average function. So the first thing that we want to do after we have imported our libraries is we want to generate the synthetic sales data, which is going to be monthly sales for 36 months. And the first thing we do in that regard is we're going to set our seed. The reason why you set your seed is so every time you run the program, it will initialize to the same values. So you do that by typing in np.random.seed, and you can type in any number you want within the brackets. So month equals pd.daterange, brackets, start equals 2020-01, comma, period equals 48, so that's 48 months. And frequency equals ME, and ME means month. I believe it's month ending. And then trend equals np.linespace, brackets, 200, comma, 500, comma, len months. So it's going to be 48 months, and it's going to be a linear trend. Seasonality equals 50 times np.sign, brackets, 2 times np.pi times np.arrange, brackets, len months divided by 12. So 48 divided by 12 is going to be 4, and that's going to be your annual seasonality. And the noise equals np.random.normal. Normal is a normal distribution, bracket 0, 20, len months, that's 48 brackets, and that's your random noise. So sales data equals trend plus seasonality plus noise. So we're going to use pandas to create a data frame. Sales df equals pd.dataframe, brackets, curly brackets, month, colon, months, comma, sales, colon, sales data. So your first column of data is going to be month, and then your second column of data is going to be sales. And sales df dot set index, brackets, month, comma, index, in place equals true. So you're going to set the index to the month. So your month is going to be your index, and your sales is going to be your column of data. So we're going to split sales data into train and validation set. So train size equals int len sales times 0.8. So it's going to be 48 times 0.8. And then, so that's going to be 80% of 48. And train, comma, validation equals sales df, square brackets, colon, train size, comma, sales df, train size, square brackets, train size, colon. So what you've done is you split your data into your training set and your validation set. So now what we're going to do is we're going to calculate PDQ. And I've already calculated it. It takes a long time to do it. But what I'll do is I'm just going to leave the code on the screen if you want to copy the code. And it takes a long time to do it, to do the PDQ. But I'll just leave the code on the screen, so if you want to stop the video and copy the code, you can. And so that's the code to actually calibrate the PDQ. And then what we have is the PDQ is the order is 212. And so what you would do is you would, all of these, to calculate the PDQ, what you would do is you would take it all out of the hash marks, because now it's in comments. And then so you would take it out of the PDQ, and then it would actually tell you what the best score is. So the best score is, in this instance, it's going to be 212. And then after you get your best score, you write that down, and then you put everything in comments again. And the reason why you put everything in comments again is because it takes such a long time to do it that you don't want to redo it. And then we're going to go through and we're going to define a model. So after we've done it, because it says print best ARIMA RMSC, and then best config best score. So I'll give you 3 numbers. And so model equals ARIMA brackets sales DF square bracket sales, comma, and then order is 212 because that's what we have determined when we calculated the PDQ. And then model fit equals model.fit. And then, so now we forecast the sales revenue for the next 12 months. So the first 36 months, what you're going to do is that's your sales data. And then the last 12 months is what you're forecasting. So forecast steps equals 12. Forecast equals model fit dot forecast bracket steps equals forecast steps. Forecast index equals PD dot date range brackets start equals sales DF dot index square brackets -1 square brackets plus PD dot date offset brackets 1 comma periods equals forecast steps comma frequency equals NE. So we're going to combine the historical and forecasted data for plotting. Forecast DF equals PD data frame brackets curly bracket sales colon forecast comma index equals forecast index. And now we're going to plot this data onto a chart. So PLT dot figure brackets fig size equals 6,4 PLT dot plot bracket sales DF dot index comma sales DF square bracket sales label equals historical sales comma color equals blue PLT dot plot brackets forecast DF dot index comma forecast DF square bracket sales square brackets comma label equals forecasted sales comma color equals orange comma line style equals dash. So now we add labels, title, and a legend. The title is ARIMA model forecasting sales revenue. The X label is date. The Y label is sales revenue. And the legend, you get a legend and then you get a grid. So now we're going to plot this. And so we've actually got a forecast. So this is your ARIMA forecasting sales revenue. And so your blue is your historical sales. That's the first 36 months. And the orange is the forecasted sales. So we've got the first 36 months of sales, and we're predicting on 12 months. And so that's it. That's your ARIMA. There are other time series analysis functions that you can use that you don't have to calibrate a PDQ. And perhaps at some point I will design a course just on time series analysis and stats models and go through all of the modules that they have in time series analysis, because we're not using all of the modules in this course, but that would be a good exercise to go through all of the time series analysis modules and stats models, just so to give you an idea of what you can do. So that concludes this video. The next video is going to be on another time series analysis subject. So I hope that you decide to watch it, and I will communicate with you soon.